Hello, I'm Rachel, and this is the electric cozy I'm building. Last time, I reinforced the fuselage for the main gear strut. Today, I want to focus on the work I did reinforcing the main gear strut itself. There's a lot to this, so let's get to it. First, I have to unwrap this large, unwieldy package, which contains the main gear strut and the nose gear strut. Both are single pieces of molded S-glass fiberglass. After setting aside the nose gear strut, I went in and sanded off the flash, or top layer, from the main gear strut. This provides a good surface to form a mechanical bond between the main gear strut and some reinforcing layups I'll be doing later. With the flash removed, the next task is to cut the gear strut to length, and also angle the ends correctly. I measured the exact length of the gear strut and found the center of the strut. I used a contour gauge to find the exact shape of the ends of the gear strut, which I used to model a jig that is inset and angled at the right points so I could draw a guideline on the strut. This allowed me to cut the strut to length and to the correct 8-degree angle all at once. With the guideline drawn, I spent a good 2 hours making a rough cut with my trusty oscillating multi-tool before sanding to final length with a belt sander. Next, I needed to remove some material from the trailing edge at these bulges here. These need to be flattened to help build the tabs I'll use to attach the strut to the fuselage. I marked the point I needed to sand to and used a belt sander to remove the material. Then I put this on hold while I took some time to do some other projects which I thought would take much less time than they actually took, including building a table large enough to lay the gear strut on, the primary reason for this delay. When I came back to this, I made some standoffs by screwing some 3-inch screws into these 2x4 blocks. I measured to make sure these standoffs were the same height, just to be certain. Looking back, having these be the same height wasn't necessary. You really just need to have a few inches of space between the strut and the table. I hot glued the leading edge of the strut to the standoffs to secure it to the blocks, which set me up nicely for the torsional layups. The gear struts are made by placing a large amount of S-glass fibers in a mold and injecting epoxy. As I said, S-glass is really tough, but all the fibers in these struts are going along the length of the strut, which means that they don't really handle torsional, that is, twisting, loads at all. We can account for this by adding a few plies of uni fiberglass to create a crosshatch pattern on the gear strut, thus allowing it to handle these torsional loads. Cutting that uni was a time. The plans call for 12-inch wide strips cut at 30 degrees from the selvage. Rather than use a protractor, I've calculated, or rather used someone else's calculations to figure out the lengths necessary. After marking the lengths, I placed a length of string on the table with one end taped at length equals 0 on one end of the width of fiberglass, and the other end taped to length equals 65.82 inches, or as close as I could, on the other side of the fiberglass. To ensure these strips are at least 12 inches wide, I placed marks at 26 inches from the string. This 26 inches translates to a 13-inch wide strip. This gives me a tiny more wiggle room than what the plans prescribe. And to foreshadow a bit, I could have gone with more wiggle room. When I pulled the fiberglass out, I pulled it over the string, then placed inch-wide masking tape on the fiberglass on top of the string. I then marked where the string was using a black marker and cut along that line. Then I pulled the next length along and repeated to get 9 strips of uni, which gave me 1 spare just in case. After that, I made a template and used it to draw lines 35 degrees from the trailing edge of the gear strut to help us align the fibers in the correct direction. The next day, my wife and I spent around 4 hours laying up this uni on top of the gear strut. We laid up 4 plies, alternating direction with each layer to make a crosshatch pattern. We used 2 strips per ply, being careful to ensure they don't overlap at all when they meet. We also tried not to have overlaps when the sides of a strip met at the underside, but we were less successful there. Not only were we fighting gravity, but there also wasn't a whole lot of area between the strut and the tabletop to work with. Also, in the area around the top, where these bulges here are, the 13-inch wide strips weren't enough, and I wish I had cut wider strips. We made it work using scrap pieces to patch it, but I wish that hadn't been necessary. Once all 4 plies were finished, we wrapped the strut tightly with strips of peel ply, both to ensure a good surface finish, but also to use the peel ply to help keep the leading edge glass in place on the underside. By this time, I had switched to a polyester that was actually meant to be used as peel ply, as opposed to polyester that I had picked up at a local fabric shop. The main difference here is that this new to me stuff comes off much easier. With the old fabric, if I don't pull off the peel ply during the epoxy's green stage, then I needed pliers and a lot of effort to remove it. With this new stuff, it just comes off even after the epoxy has fully cured. Hashtag not sponsored, but I'll link it in the description for those doing composite work. Tightly wrapping the fiberglass with peel ply worked out great. It did such a great job just keeping the fiberglass in place, especially around the underside. We had a bit of a tough time removing the strut from the standoffs. The standoffs at the ends came off easily enough, but the middle one did not want to come off at all. At one point, I tried to use a hacksaw to cut it off, but I soon realized that was a very bad idea. If I succeeded, then I would have the much harder problem of trying to remove the screw head. Instead, we clamped the standoff block to the table and twisted the strut to pop it off the middle standoff. With the strut removed from the standoff, I sanded it to prepare it for the next glassing. Then I turned it leading side up to clean up that side where I did a lot more sanding. Remember that, we'll come back to it in a bit. I also removed the extra glass at the ends at this point as well. I had noticed some issues in the top layer of glass which needed patching. To help with that, I traced a template on paper, then used that to help cut out the patches from uni fiberglass. Once that cured, I flipped the strut back to trailing side up and did some more sanding as surface prep for the brake line conduit. But before I installed the conduit, I had to figure out where it would go. The brake line conduit starts at 8 inches from the end of each leg and ends 16 inches from the center point. During the first torsional layup, I had lost the original reference to the center, so I had to find it again. I taped a piece of string to the trailing edge, marked where the edges were, then I pulled it off and folded it in half and marked that as the center point. I marked where the conduit should be, then I retaped the string and transferred those marks to the strut. I installed the conduit by using hot glue to tack it down onto the trailing edge. I cleaned up the excess glue that dribbled down the sides. And I used 2 layers of aluminum tape to provide a backing for this conduit. This wasn't that great. It turned out a bit wavy and I should have used something thicker, maybe aluminum flashing, but it worked out and I will be adding proper fairings down the line anyway. With the aluminum tape added, I cut some bid at 45 degrees from the selvage. I used that to add 2 plies of bid on the other side of the conduit from the aluminum tape, making sure to add micro to fill in gaps between the bid and the conduit. Once this cured, I removed the peel ply and the aluminum tape. I sanded the fiberglass to prepare for the second set of torsional layups. And yes, this does mean that only one side of the brake conduit gets a bid backing. While I was preparing the fiberglass, I noticed a few air bubbles underneath the bid, which I fixed by drilling holes and injecting the bubbles with epoxy. Then I sanded down the area to prepare it for glassing, flipped the strut over onto the leading edge, sanded some more, raised the standoffs by adding some blocks to add more clearance under the strut, and marked the 35-degree angles on the bleeding edge. With this prep done, it was time to cut yet more uni fiberglass. This time, both to compensate for that earlier wiggle room not being enough, as well as for the extra space required for the brake conduit, I cut 18-inch wide strips. And now, time for the second set of torsional layups. Another 4 layers of uni with the leading edge facing up. Thankfully, my wonderful wife had more time to help with this large layup, which meant these only took about 4 hours real time. The plans call for you to lay up the brake line conduit and this trailing edge to form somewhat of an airfoil shape. You're supposed to alternate which layups go to the full end of the trailing edge and which end just before the conduit, as shown here in figure 11. However, I misread that and had every ply go to the full length, which isn't really a problem. It's less than 100 grams of extra mass. I'm also not the first person to make this mistake, and it's not worth bothering to correct, but it is worth mentioning. You might also notice that, unlike the first set of torsional layups, we're not bothering to wrap this glass around the bottom side. I'll get back to that shortly. After the layup cured, we removed the peel ply and the leading edge looked great. So we flipped it over and I set off to remove the extra fiberglass and fill in any voids. And this is when I realized I had made a pretty annoying mistake. Remember all that extra sanding on the leading edge after the first torsional layup? I wasn't just preparing it for the additional layups. I was removing the torsional layups on the leading edge down to the bare strut. Look, okay. Here's figure 8 of page 9.2. It depicts a cross section of the main gear strut and also the first torsional layup. Note how the depiction of the first torsional layup doesn't exactly cover the underside. So I thought, hey, this isn't necessary and probably wasn't something I should have done. So I'll remove the glass from the leading edge by sanding it off and save some weight. Makes sense, right? Not only is this silly, because it's just a couple 100 grams of fiberglass, all this would mean is that my gear strut would be stronger than I thought it had to be. But also, well, let me show and read this line from the 4th paragraph of step 2 on page 9.2. Try to get the fibers as close to meeting at the leading edge as possible. Which we had done. There's more. Remember how we didn't bother wrapping the fiberglass around the underside of the center and ends when we did the second torsional layup? Same mistake, made for the same reason. When I realized this, I started to panic. What do I do about this? Do I need to sand off all the uni and redo the torsional layups? That would suck so much to have to do. Thankfully, as it turned out, no. I reached out to the Cozy Builders community, explaining my mistake and asking what I should do. And after sending a clarification, I got advice on how to approach this. The basic gist is no, I don't have to redo anything. This can be fixed just by adding additional layers of fiberglass. Basically, I just need to add 4 plies of uni to the leading and trailing edges in the same orientation as I would have for the torsional layups. The bottommost ply needs to be as wide as the gap is, which is 1/2 inch for most of the strut, and each additional ply needs to be 1 inch wider to cover more area. I made a bunch of templates for this. Starting with the trailing edge, I made 4 templates for each section, of which there were 3. The center and the edges after the brake line conduit, for a total of 12 templates. I wetted out a single ply of uni on each template, cut out the strip with the plastic backing, then transferred that to the strut. The first time I did this was a bit frustrating because I tried to remove the plastic backing at the wrong place and ended up distorting the fibers way too much. I made similar mistakes the next 2 times I tried the first center section ply, and afterwards I decided to combine the first and second plies before laying them up on the strut, which worked out. After this frustrating start, the rest of the layup went on well. The trick seemed to be to pull off the plastic from one of the ends instead of near the center. Sadly, I didn't check this too hard when we were finishing up, which led to a few small bubbles between a couple layers, which thankfully didn't take long to fix, just drill and inject epoxy. For the leading edge, I split it up into 5 decently straight sections and made 4 templates for each section for a total of 20 templates. And this went on much more smoothly. I remember to only pull the plastic off from the ends, resulting in a much less frustrating layup. As usual, I peel applied the entire thing to ensure a better surface finish and to absorb excess epoxy. Once the epoxy cured, I pulled off the peel ply. Is it still ASMR to watch peel ply peels? I hope so. After the peel, I trimmed the excess epoxy from the end and did some light sanding on the fiberglass. I did see a few voids, especially in some spots where the fiberglass transitioned from the first to the second layer, but there wasn't anything that was large enough to require me to sand it off and redo anything. The repair just needed to be drilling holes and injecting epoxy to fill the voids. And then afterwards, I put on masking tape to seal the epoxy in while it cured. Thankfully, that was all I needed to do for the repair, And after removing the masking tape, it looked great. Yes! And with that, I'm finally done with step 2 of chapter 9 of the Cozy Plans. It wasn't even a whole page. If you like this and you want to see more, please leave a thumbs up and consider subscribing. Feel free to leave a comment too. It's been great to read all the encouragement. Until next time, thank you, and I hope you have a great day.